to hop over this linear regression example. So in this linear regression example, we will try to build one small y equals to wx plus b linear regression. Okay, example. Completely scratch. We'll try to figure out all the b values and w values basically for the given scenario of y and x. And basically it's a recap for your PyTorch tensor learning. So whatever tensor stuff you have learned in the previous videos, we'll try to apply those in this video. So before starting, the plain assumptions of the linear regression: the first thing is linearity between y and x, your dependent and independent variable. There must be one linearity needs to be exist. Then second one is independence of error, so the residual or the epsilon term are independent of each others. There is no communication, that means it will be completely random. So if you do a plotting of your error values, you should get a normal distribution. Then third one is homoscedasticity, that means the variance of the residual is constant across all level of the independent variable. Okay, so what does this implies? That the spread of residual should be roughly same along the regression line. Okay, then normality of the residuals, that means the residuals are normally distributed, that already we have mentioned here as well, right? Independence of error in this term. And then no multi-collinearity should exist, that means those who are independent should not have a collinearity, high collinearity between. So that's why to eliminate those from a basic neural, sorry, not neural network, from linear regression, we have L1, L2, all those methods, right? And finally there's exogeneity. Okay, there should not be any correlation between the independent variable and the error term. Okay, so these six are the basic principles of your linear regression, so we have also gone through. Now if I print the cars, okay, pd.read csv for printing the csv file, or this car file, basically I'll get blah blah car name, mpg, cyl, displacement, horsepower, okay, weight, gear, carb, all those stuffs. So I'm taking the weight and mpg as a linear relation. Okay, so it's my assumption. Based on these six assumptions, I'm assuming. Okay, so to just give you a hint, I cannot directly go into the model coding part. So I'll do one C-bond scatter plot, SNS scatter plot. In X I'm putting the weight, in Y I'm putting the mpg, in data I'm giving the cars data set. So remember how we are doing the syntactical thing, right? But in the Gen AI era, the codes you will definitely get the syntax, there's no need to remember anything. And then I'm doing another regression plot on top of it. Okay, and both I'm plotting in the same graph. So you can see first one comes as your scatter plot, and then you can see a pure equation between weight and mpg. Okay, now our main goal is to use this to, okay, and what we are going to build, we are going to build a relation between mpg and weight using linear regression. And the main target of this video is to do it in a PyTorch tensor manner. Okay, so first for x term, which is our weight, I need to convert the data into tensor. So as you can see, I have my cars data. From there I am fetching the weight, and then I am fetching the values, and listing is as x list. Okay, I'll just copy this line in code, I'll do that. Okay, and in code let's just print. So I can see all the values of my weight value comes in a array format here, right? So if I print the type of this, okay, I can do that. I'll get it's a numpy n dimensional array. Okay, and the same value I will also get. Okay, this is the dot method, and there is another index method, right? So if I index this one, I'll also get the same value, right? But what will be the difference? No difference, right? The type also remains same, right? Okay, and let's just give this one as x1, and if I do one assert of x list, and let's just run it again, copy it again. Okay, something went wrong, is it? statement maybe blah blah. Okay, got it. Is assert statement. Okay, I'll see there is no error it is producing, right? That means this list and this list is same, so both the method will give us same result, right? Now I have my x value. Okay, what I'm going to do, I'm just going to reshape and convert this data as the required format. That means -1 comma 1 will give me my reshaping the array into my required dimension or required structure basically. And second, I want my response variable, that is my y list, to be as list. Okay, and once that is done, I'll also convert it into the required numpy array shape. Okay, so this one is also done, and once both the thing is done, I'm just creating. Why we did it, I'm just sharing here. So let's see, I have numpy array, right? I have this numpy array. Now I'm just going to create one x tensor from numpy and one y using the tensor method. Okay, both the methods are valid, and let's just print x. I can see the tensors. Okay, clear selected output, and in code I can also, let's just print a few. Okay, you can see it's a tensor. So now your numpy array got converted into tensors, right? Now what is the target of this video? Basically the target object is y equals to w times x plus b, where we have y and x tensors ready, right? So target is to find w and b of any regression problem, right? Linear regression. So let's assume that my w will be one random value random tensor using torch, and just giving the values, and the same thing for bias, and you just print w and b and see what is the values there. Okay, something. Okay, is there any w out there? So you can see our random value between 0 to 1 is assigned to the weight, and for bias also same thing. And remember, it is I mean not multilinear linear relation we're doing. We're just only taking one single x and single y. That's why we need to figure out one single w and single b. Now let's assume that we are going to run for 100 epochs. We have 10 to the power minus 3 as our learning rate, and we need to do the learning. Okay, so first we'll just do one forward pass, that means prediction of wx plus b. Then you need to calculate loss. For loss we're using MSE, that means y prediction minus actual y, and then squaring up. Okay, and once that is done, we are using one backward pass. So loss tensor, this objective dot backward, this will give us the backward propagation gradient and all those stuff. And once that is done, we'll just calculate the extract loss value. So what will be my loss value? My loss value will be this loss tensor dot data, and we are just getting the first index, as there is only one w, right? So for only I mean for a single basically input, we are updating the weights, right? So now with torch.nograd, as we have to reset, right, what we are going to do, we are just updating the value of w and b. Okay, so how we are doing that, that is your w and b. So how it is getting calculated, w and b is there, and then you have the final output, which is your y predict, right? That is getting predicted by the tensors. So now w equals to w minus your gradient times learning rate. That's how you calculate the upgradation, right? And once that is done, let's make the gradient of the learning to 0. Okay, and once that is done, for every 10 epoch we are just printing the loss value. Okay, and let's repeat for 100 times, right? So you see the loss value what we are getting from this backward pass, right, is getting reduced which every run, right? First it is around 3, then 2.5, then 2.1, then 1.8, blah blah blah, and in final after 100 epoch it is 0.6. So that's a very basic linear regression that we have implemented from scratch using PyTorch. So what we are doing, first we are calculating the y predict vector or tensor. Once the y predict tensor is getting calculated, we calculate the loss using loss tensor. Once the loss tensor is calculated, we use the backward method to calculate the backward pass. Once the backward pass we calculated, we need to calculate the loss value. then we calculate the loss value, and once we get the loss, we just loss value once we get, that means there need to be some correction. And how we are doing to that correction, we are going to make the correction using gradient. So we are getting the gradient of w and b, and we are multiplying with the step value, that is our learning rate. And once that is done, we are making the adjustment, and then we are again making the gradient to 0 for our next set of learning. And for every 10 step, 10 iteration, we are printing the loss value. Okay, so this is what a simple linear regression cycle we using gradient descent algorithm looks like, right? So once that is done, okay, so we have our weight and bias ready, because y equals to wx plus b here, so we know the b and w. Okay, then from that we'll get the slope, we'll get the bias term. Okay, and once that is done, then it is we are just printing the PyTorch vector flow here. Okay, what is happening? So you see, first there is one accumulate gradient, then you have multiplication backward, then accumulate gradient again, then add back.